So I saw this question in the NCERT textbook, and of course, it's a typical math question where we have a story to get into a situation so that it doesn't look intimidating to anyone. And at the end of it, we need to find the area of this triangle here. The sides are 100, 100, and 160. That's the takeaway, and this is a side with equal length, so it's a rhombus. So if we are to look at it solving that way, we name them A, B, C, find the semi-perimeter, put them in the formula and get the area as 4800 meter square, which means the area of this rhombus is 9600 meter square. But that's not the point of this video. It's not to show you how to solve it. The point is, here's a rhombus or a rhomboid. I'll name it ABCD, and depending on where you're coming from, we call it rhombus or a rhomboid. And all rhombuses have the same properties, right? We studied them as properties of rhombus in somewhere, if you remember, that their sides are equal, opposite sides are parallel, and diagonals are perpendicular bisectors of each other. And of course, a diagonal divides it into two congruent triangles, right? Which is why we are able to get the same area for both of them. Let's look at this property in particular, which means that diagonals are perpendicular bisectors of each other. If we draw out this diagonal, we get the other two lengths as 80 meters, right? These two lengths as 80 meters. And of course, we have a right angle triangle here, which brings us to Pythagorean theorem, which we studied separately in another place, right? Because of Pythagorean theorem, this length, which we don't know, can be calculated out to be 60 meters, or the diagonal AC will be 120 meters in length. Now let's have a look at the fourth property, which says that the diagonal divides the rhombus into two congruent triangles. So if we take the diagonal AC, for example, the triangles are ABC and ADC. They are congruent because of this property, and their areas have to be equal, because two congruent triangles cannot have different areas. So if the rhombus is 9600 meter square, these two triangles should have an area of 4800 meter square. But their sides are 100, 100 and 120. Which brings me to the question that if we calculate the area using the Heron's formula, we should be getting 4800 meter square. I mean, all of this put together kind of made me feel like, okay, something should break. All of this cannot be true all at once. But when I tried to figure out if it broken, I discovered something shocking. So these are three things which we learned separately at separate times, and we are trying to see if all of them are able to be consistent within the realms of one, without violating the terms of one another. So we have a rhombus, let's say, and because of its properties, like ABC and ABC should have an area of 4800 meter square, because diagonal AC divides it into two congruent triangles, and ABD also should have a area of 4800 meter square, because diagonal BD divides it into two congruent triangles, right? And then we have the Pythagorean theorems. Now it's taking a backseat because we are not so concerned about it. And if we use the Heron's formula to find the area of these two triangles, ABC and ABD, we should be getting the same number, 4800. I mean, the sides are different, but how? So let's calculate the area of triangle ABC first. So the semi-perimeter is 180, and the area is an expression which is the square root of 180 times 80 times 80 times 20. So simplifying, let's leave it like that. If we look at triangle ABD, then the semi-perimeter is 160, and the area turns out to be 160 times 60 times 60 times 40, right? 160 minus 100 is 60, and 160 minus 120 is 40. That's how we get these numbers. And of course, these two have to be the same numbers. Are these the same numbers? Can we say that without calculating? Let's see. We have to see if these two numbers are equal. Of course, let's just take them out of the square root. And here's how we have factorized the whole expression here. This turns out to be this. And the same thing has been done for this product. We have expressed them in terms of only prime factors. Now if we combine all the prime factors in each of these expression, they turn out to be the same. Even I was shocked. They turn out to be exactly the same. There is no discrepancy whatsoever. The prime factors are the same, 2, 3 and 5. The exponents on each of these factors are the same, and this blew my mind. Everything is consistent. Of course, these two are equal that way. Now this made me wonder, okay, let's say that the sides of a triangle are 100 and 100. It's an isosceles triangle. And we know that the area is 4800 square units. What can be the sides, what can be the length of the third side? And we found out that it could be either 160 or 120. Do we get the same if we calculate it that way? Let's see. Of course, it should be that, but we have to see if we get the same on calculating. Let's call it x. We don't know that length yet. And if we divide an isosceles triangle into, like if we divide the base into 2, that line will be perpendicular to that base. Of course, we know that it's a property of an isosceles triangle. So these two will be x by 2 meters in length or whatever unit, and the height will be this one, root of 100 square minus x by 2 whole square, which evaluates to be this expression here. Alright, moving on. If we find the area using half base times height, base is x and height is what we calculated, the intimidating figure we calculated till now, right now. Of course, this takes me into simplification of this equation. Of course, like we just retain the square root on one side and square both sides. Of course, we get an equation in degree 4. And of course, we have only x square, so this can be treated as a quadratic equation in x square, where x square is, we can calculate x square using the formula. This is very intimidating. I used Google Calculator for this. So I get 40,000 plus or minus 100 and, sorry, there should be one less 0 here, 11200 upon 2, which means x square can either be 25600 or 14400. Interesting. So when x square is 25600, x is either plus or minus 160, and when x square is 14400, x is plus or minus 120. Wow. And since we know that the lengths cannot be negatives, we are avoiding any value with a minus sign, so x is either 160 or 120. This says that it's not only the case that when the sides are 100 and 100, okay, let me rephrase this. This says that if we have an isosceles triangle with 100 and 100 as one sides, and the area is known to be 4800, the sides can either be 160 or 120. It also says that x cannot be any other value. Wow, it blew my mind. If you like this video, please share your comments on this video. Thank you.